Hi everyone, I'm Sushmita. Now I'm going to talk about the project which is a local AI chatbot. We have built it with a front end and back end. For front end we have used the Streamlit, and for back end we have used the LangGraph and Gemini 2.5 Flash AI model, which this is an AI model. So the main purpose of this project is users can have an interaction with AI. So whenever the users can ask any questions or they want to share any messages, the AI model will give the answers to them, and it will have a smooth conversation. So the uh, workflow of this project is it will start from user input. User will give the input and in a Streamlit. So by using the user interface, from user interface we'll give the uh, question. What happened here is this message will go to a message history, and then by using the invoke method, it will be sent to the backend. So by using the invoke method, we'll send it to the backend, and from backend, what it will give the response in return through Streamlit. So this is how the workflow will be. What happened in backend is it will use the LangGraph. So it will uh, take the input questions and it will give the return in response uh, from the front end. So that AI response will be stored in the memory saver. So this is a workflow of the project. And in front end, we have used the Streamlit app. So how the front end will work is it will display the user chat. It will take the user input and it will give the AI responses. And from in Streamlit only, we'll give the thread ID for the each thread, and that thread ID should be unique. And here, by using the invoke method, we'll send that user input to the backend, and we'll get the AI responses. So this is a front end. This is how the front end work. And now I'll show you the execution of the code. So this is a backend file. These are the importations I have taken. This is a type dict annotated list. OS means operating system. This is for using. This is for getting the files whatever we have given in the .env. So this is used to. This is a load .env. Used to load the details whatever we have given in this .env file. And this is a state graph used to. um Means use it to start, and this is the end, use it to end the graph. This is a base message, this is the add messages. uh, these all the message objects. This is a memory saver, use it to store the history. And this is the system message, and this is a chart Google generative AI, which is used to. Why I import this is why, because I have used the Gemini API model. So that's why I have imported it. So this is a load.env, which is used to load the environment. And this is a Gemini API key. Uh, what I have given the API key in the .env file. This is the API key I have given in the .env file. So the name I have given to this is Gemini API key. And here I am using this Gemini API key. So if I don't find any Gemini API key, have to raise the value error like Gemini API key is not set in the .env. So this is a model, Gemini model. What type of model here I am using is Gemini model is Gemini 2.5 Flash, which is a free version. And this is a default system prompt I have given in the .env. So this is how here I am using it. And this is a class I have taken message state, and I am passing the type dict. So why? Because I'm using this is a base messages and add messages. Whatever that messages will be list will be annotated, and it will be stored in a messages variable. And this is a setup of the LLM. This is what type of model here I'm using is Gemini model, and this is a API key whatever I have taken in the .env Gemini API key, and this is a temperature, and this is a max output tokens. I have given as 512, which will give us the quick responses. And this is a chart node function. What the parameters I have taken here is a state, which is a message state, and uh, it will store the messages into this variable, messages variable, and if not messages or not is instances or messages are zero, it will give the default system prompt. Uh, it will this is llm dot invoke method. What this invoke method will do is it will give the user questions to the backend. This is how invoke method works, and we'll get the response from the backend. That response will be stored here, and that response will be returned here. So this is a check pointer equals to memory saver, which is used to store the message history. And this is a state graph. Here we are creating this state graph message state, and here we are adding the node as a chart node to this graph, and here we are also adding the edge as, and this is the another edge we are adding. So where how it is starts means it will start from start. It will go from start to the chart node and from chart node to the end. So this is a workflow variable. Here what I am doing here is graph. I'm compiling this graph. Check pointer equals to check pointer means storing. So this is what I am importing in front end. This is what the Streamlit app imports. So this is all about the backend Gemini, and this is a front end file. So these are all the importations I have taken. UUID means unique identifier, which will be given to the thread. So that's why I have imported it. From typing, I'm importing the list, importing the Streamlit for front-end user interface, and I'm importing the .env file to load the Gemini API keys. And these are the human messages, AI messages, and this is a base messages. These are all the messages. Means like questioning or getting responses. These are all the messages. And from backend, we are importing the workflow as I told before. So this is a function, get or create thread ID function. What I am doing here is I'm creating a thread. If I don't find any thread in the session state, I'll create a thread, and I'm giving the unique identifier, means unique identifier number for each thread. Here I'm giving it and returning that thread ID. So what happened here is this is a init message history. So if message history is not in the session state, I'll give the list of questions and will be given to this message history. And this is a render chart history function. What happened here is it will loop the messages in the session state of message history. So it will show us the user. This is it will show how the user chart will look like. This will show the message content of the user, and this will show the response message from the AI. What we are getting the responses that will be stored here, and this is a stream text function, and here I am taking the text as a parameter. So it will return as the it will split the tokens and it will return those tokens. Means output, whatever I output we are getting from the AI, that will be splitted and it will give us the tokens. So this is a load.env. Uh, why we are using it is to get the Gemini API key from the .env file. So this is all about the styling, giving the page title. So the page title here I am giving as chatbot, and the layout is centered, and the title is chatbot, and the caption is run successfully. So this is a subheader I am giving, and here I am giving the thread ID to this, from where I got this from create thread ID. Here I got a ID that will be given to this variable, and it is returning that way thread ID in a font I have given here is. So this is a button, start new conversation button. Uh, Same, it will return as the thread ID and it will rerun it. This is the init message history. We are calling, and here we are calling the render chart history function. So this is the user input. Whatever the input will be given to uh, AI model, that will be by this line only. st.chart input, type your question here. So this is where user can give the input. So if the user gives the input, that will be shown, that will be visible in the UI interface. So whatever the message we given user given, that will be append to the message history here. And here we are giving the thread ID to this variable, and here we are giving the configuration. So this is where the call workflow. So here we are using the invoke method, which is used to um, uh, send the message to the backend and to get the responses. So this is the result state. Result state means the response we got from the AI will be stored here. If the last message is from the user, uh, then we'll return an error like I could not generate a response. Please try again. If the last message is from the LLM, it will be fine. So here, by using the invoke method, will give the backend will give us the responses that will be written here, and that response will be stored into the message history. So the AI message will be append to the message history, and all will be saved in the memory saver. So this is a code, and this is a requirements.txt file. So what we are taking here is Streamlit, Python.env, LangGraph, LangChain Core, and LangChain Google Gemini. And this is my .env file. Here I'm taking the Gemini API key, and here I'm giving the system prompt. And I have created a virtual environment for this. Now I'll run it. So I'm going to the backend folder and I'm activating the virtual environment and I'm calling the Streamlit. So this is how the front end will look like. So this is a caption I have given session. So this is a thread ID variable and this is a thread ID I have given to it, which is a unique one. And this is a new chat conversation button. And this is a each browser tab has its own thread. It will show us the message like this. And this is a title I have given as chatbot. And this is a caption run successfully. And this is a input box where the user will ask the question or give the message. Here I'm giving the hi message. So here I'm getting the response. Now I'll ask a question. So it is giving me the responses. So it is giving me the responses. So this is how the project will look like. So this is a this is about the project. Thank you.